Hey there, in this video we are going to look at recognizing graphs of linear functions and review how we can do that specifically with some multiple choice questions. So in this video, again, we will look at multiple choice questions, specifically looking at how to identify or choose the graph of a linear function given different pieces of information. So given ordered pairs, given a table, which is essentially just a list of ordered pairs in a table format, an equation or multiple equations. So that's what we'll look at today. So our first example will be identifying a graph given ordered pairs. So here we see four ordered pairs, -1, 4, 0, 2, 1, 0, and 2, -2. Remember, the first number is your x, the second number is your y. So that is something good to keep in mind when you're looking at which graph is correct. So first thing we're going to do is we're going to see which of the graphs is actually going to represent those 4 points. So many ways that you can go about this. You could look at the first graph, for example, and see this first point right here on this graph is going to be -2, 2. And we see that that point is nowhere on our list. So we could go through and eliminate that way. However, sometimes that isn't the quickest way because sometimes there are multiple graphs with 1 or 2 points that do come from the list. So it just kind of depends on what you see first and what you are quicker in. So another option would be to look and see, okay, is -1, 4 on each graph? And let's just check that. -1 up 4 would be right here. That is not on graph A. So that's two different ways, two different routes that you could go to eliminate any graphs that are not correct. So we know A is not correct. Whichever method makes more sense to you or is quicker to you, use that. Let's look at B. So -1, 4 is this first ordered pair. Then we've got 0, 2, and 0, 2 is right here. So far we have 2 of the 4 points. And then we have 1, 0, which is this point right here. And then 2, -2, so right 2, -2 is down 2. That's the fourth and final point. So this one we're thinking is our answer, but just to eliminate the others. We have on C, -2, 2 again, which is not one of our ordered pairs. You can see that it's in the same spot as this point on choice A, so we can go ahead and eliminate choice C. And then on D, you can see right here, this first point that I see up here is 1, 4, and 1, 4 is not one of our ordered pairs on this list. So again, we can use that as a way to quickly eliminate option D. So B would be our answer on this one. All right, so our second example is going to be pretty much the same thing as what we just did. It's just written as a table instead of a set of ordered pairs. Remember that in a table, our x and our y that are matched together are really representing an ordered pair. So this is the ordered pair 1, 5. This is the ordered pair 1.5, 3. We've got 2, 1, 2.5, -1, and 3, -3. So we have 5 ordered pairs here really, and then now once you realize that, whether you write it out or you just read it that way from the table, we see that we can do the exact same thing that we just did on the last one. So if we look at A, we can see 1, 5 is the first ordered pair, and that's here. Then we've got 1.5 up 3 is the second point right here. Then we have 2, 1, and that is another point on this graph. Then we have 2.5, -1. Which is right here. And then we have 3, -3. So it seems like A is our answer. Let's go through and just make sure. So on B, -3, 3 is this point right here. -3, 3 is not any of our points. So B, we can go ahead and cross off. Looking at C, this point that I see right here is 3, 3. And again, that it does not match any of our points. So I can go ahead and cross that off. And then looking at this next one, 1, 5 is one of our points. So we can go ahead and continue to check. So that is this first point. Then we have 1.5 up 3, which would be right about here, which is not on that graph. Or if you want to check one that is on the graph, you can see 2, 3 right here that is on the line. That is not one of the points in the table. So that tells us that D is not the correct answer. So A is our answer on this one. All right, so the next type is identifying a graph given an equation. So remember, when we look at equations, we like to look at specifically y equals mx plus b when we are graphing, so that's slope-intercept form. Remember that the m represents our slope of the line, and remember that slope is always rise over run. And then our b is going to represent our y-intercept, which is the point where it crosses the y-axis. So here or here on the specific lines that we are looking at. So my suggestion would be to take this equation and quickly get it into slope-intercept form, meaning get y by itself. If you can get y by itself, then you know the slope and you know the y-intercept, and you can figure out which line is correct. There are other ways to do this as well. You can pick points to plug in, but sometimes that takes a little longer, and sometimes you have to keep guessing points. If there's a point that works on 2 lines or something like that, you kind of have to be strategic if you're going to go that route. So I would go ahead and get this y term by itself. To do that, I'm going to add 8 to both sides. So we have 2x plus 8. Remember, those are not like terms, so we cannot combine them. Equals 4y, and negative 8 plus 8 cancels out. And then we have divided by 4 on both sides, and we have 2x divided by 4 and 8 divided by 4. So 2x divided by 4 becomes 1/2 x. 8 divided by 4 becomes 2. And then 4y divided by 4 becomes y. So to flip that around and read it how we typically do, y equals 1/2 x plus 2. Now, in doing that, we went ahead and found what our slope and our y-intercept are. So our slope is 1/2. Notice that is a positive slope. Because that is a positive slope, if you realize your slope of different lines, then you know that C is a positive slope and D is a positive slope. All right, but A and B are both negative slopes. They're going down from left to right. So we can right off the bat eliminate A and B because those are not possible options since they both have a negative slope, the blue and the green here. So then we go on and we check our y-intercept, our B value. So our B value here is positive 2, which means out of line C, the orange, and line D, the purple color, we see orange crosses the y-axis up here, purple crosses down here, and because ours is a positive 2, that means line C is our answer on this one. Line D is not because it has negative 2 as the y-intercept, not positive 2. So that is one way to do it. Again, there are many ways that you can figure this out, but that would be, in my opinion, probably one of if not the quickest way to do that. All right, so the final way is, or the final example is identifying a graph given 2 equations. So we're really going to treat this very similarly to the one that we just did, but we have 2 equations now that we are looking for. So I'm going to go ahead and take 6x plus 5y equals 10, and 5x minus 3y equals 15, and I am going to get y by itself. So 6x plus 5y equals 10. If I want to get y by itself, I subtract 6x from both sides. We get 5y equals negative 6x plus 10. Notice I put the negative 6x first before the 10. You don't have to do that, but in y equals mx plus b, the mx typically comes first and the b comes second. Again, it doesn't matter. You could have done 10 minus 6x, and that's fine too. Just make sure if you keep it the other way around that you choose the correct numbers for slope and y-intercept. So then we divide both sides by 5, and that gives us y equals negative 6x divided by 5 and 10 divided by 5. Negative 6x divided by 5 cannot be simplified, so that's going to be negative 6 over 5x. 10 divided by 5 is a positive 2. So now I can go ahead and determine that my slope, my m, is going to be negative 6 over 5, and my b is going to be positive 2. All right. So looking at this, if we know that b is positive 2, we don't know the other line. We don't know anything about it right now, but I do want to point out if you wanted to, you don't have to, but if you wanted to, you could go through and check that b value and see. For example, looking at all of these options, we need at least one of the lines to have a b-value of 2 for this to be possible to be the correct graph. Because no matter what the other one is, we know the b-value, the y-intercept, is 2. So if you look here, we have 5 and -2. So we can go ahead and cross out A as not a possibility. B, we have -2 right here and -5. Neither one of those is 2, so that's not going to work. C, we have 2, so that one can work. And D, we have 2 right here. So both of those can work. So C and D are options right now. The other thing that you can look at is that one of the, at least one of the lines need a negative slope. So out of C and D, you can see that this one has 2 positive slopes, so C can actually be eliminated, and D is going to be our answer. So D is our answer on this one because we know that one of the slopes needs to be negative, and because we know one of the lines needs B to be 2. Now, let's pretend for a second that it didn't work out that way, and we weren't able to decide that from one of the equations. Let's talk about that second equation as well. So if you needed to go that step further and you didn't make that connection and eliminate those as you go, you can still go ahead and get y by itself in this equation. So we'll get -3y by itself by subtracting 5x. And then we get -3y equals -5x plus 15. And then we divide by -3 on both sides. That gives us y equals, and then -5x divided by -3 and 15 divided by -3. So I'm going to go ahead and write that over here. Y equals -5 divided by -3 is just 5 over 3. And then we have x. And then 15 divided by -3 is -5. So in this one, our m is positive 5/3. So we have a positive slope. And our b is -5. So again, you can go through and see this one does not have a -5 as a b value. So A definitely, again, can't be there. B does have -5, but remember we said it didn't have 2 as a b value, a y-intercept of 2. So that one can't be it. C has 2, and it appears to potentially have -5, but we can rule that one out because it's 2 positive slopes. Again, just as a reminder, and this one had a negative slope, that first one we did. And then this one, again, we do have -5, and then you could even go one step further and check those slopes if you need to. One of them is positive, the one with the y-intercept of -5, and then the one with the y-intercept of 2 is negative. And then if you would check them, you would see it would be -6/5 and positive 5/3. So again, that is just an even more detailed reason why D is the correct answer. There's a lot of ways you can go about eliminating on those types of problems, depending on how much you know about slope-intercept form, which is y equals mx plus b. So hopefully that helps with that a little bit. Let's go ahead and summarize. So in summary, we have just a couple of reminders. If we are given an equation or equations and asked to find the graph, then we want to get it into slope-intercept form, and then we're going to use m and b. Remember that m is the slope and b is the y-intercept. So the y-intercept, again, is your b value, the slope is your m, and you can eliminate any incorrect y-intercepts or eliminate any slopes, and really you could do that in either order. I find the y-intercept is typically easier to determine or figure out in terms of eliminating answers. However, if you look at slope as just a positive slope or a negative slope, that can help you to eliminate some answers potentially depending on those multiple choice questions. All right, and then points, remember ordered pairs will be written as a list of ordered pairs in parentheses with commas between the x and the y. Tables, we will see with an x and a y either row, or it could be vertically like this, an x and a y column. But remember that tables are really just a list of ordered pairs. Any of the numbers that are together, for example, these, or these, or these, or this way, those are really just ordered pairs. And again, that's always x comma y. So just keep that in mind, and then you're going to use those points and look for those points correctly plotted on the graph. And then you can use a process of elimination, or you can check each of the individual points. It's just for time's sake, eliminating options is always helpful.